Okay, so today we're going to look at how to solve non-homogeneous linear differential equations. So, like I said, it's called the method of undetermined coefficients. We've talked about before, if you have a non-homogeneous linear differential equation, the first thing that you do is solve the homogeneous differential equation. So set your equation equal to 0 instead of that g of x. That's what we did before in 4.3, where you found the complementary function. So we looked at the auxiliary function or the characteristic equation. Those are both the same. Set it equal to 0, found the roots, and that would give us the complementary function. So that's solving homogeneous. Now, in the case where it's non-homogeneous, you're going to solve the homogeneous equation, find the complementary solution. Then you have to solve the non-homogeneous part, and it gives you what's called a particular solution. And then we've talked, for a non-homogeneous linear differential equation, your solution will be y equals your complementary solution, add your particular solution. So these are definitely more work than what we did in 4.3 because you have to solve two different equations. You have to find the complementary function, you have to find the particular solution. One thing to note, we cannot use this method whenever we want. This method only works for functions we know how to annihilate. So if there's a function we don't know how to annihilate, you're not going to use this method. 4.6 is another method that you can use. Yesterday, when we looked at annihilating functions, we looked at polynomials, exponentials, sine, cosine. So anything else we don't know how to do. What we're going to do today, I'm going to do one example with you, and then you guys are going to do one. So here is the example we're going to do. Okay, this is the part that 4x squared is what makes this non-homogeneous. Solve the homogeneous one. So turn that 4x squared into a 0 and solve that. Why are some of you not reading anything? Look back at your notes. If you don't remember, look back at your notes. You guys have notes on this. It's in section 4.3. Don't just wait for me. When you have your complementary solution, check with the person next to you. Make sure you got the same thing. Brendan, you have something to
Oh, I hate doing sums.
Okay, I'm back. First step, solve the homogeneous differential equation, which is what you should have done. So you look at the auxiliary or the characteristic function. So this is m squared plus 3m plus 2. equals 0. Factor, we get m plus 2, m plus 1 equals 0, m equals -2 and -1. You guys agree so far? Okay. I don't know if you put a C here. Make sure you put a C so you know that this is the complementary solution. It's not the full solution. We should have gotten C1 e to the -2x plus C2 e to the -x. Okay, it doesn't matter which one you call C1 and C2. Okay, that is what we've already done. So we found the complementary solution. Now we need to figure out what to do with that 4x squared. Okay, so next step is we need to annihilate that 4x squared. What would we use to annihilate the 4x squared? D cubed. Okay, you are going to multiply both, this is really important, left-hand side and right-hand side of your equation by d cubed. Okay. Left side we're going to multiply by d cubed. This is d squared plus 3d plus 2. I'm going to factor that. So that's really d plus 2, d plus 1. We're applying all of that to y. If we apply d cubed to the right side, we're going to get 0. Okay, so this is new. This comes from right up here, just changing an m to a d. Yeah, we did that yesterday. And if you forgot, now you know. Okay, we good so far? Okay, this will help us figure out the general solution. Our general solution is going to contain that complementary function. So it's going to be that c1 e to the -2x plus c2 e to the -x. This will give us that particular solution. So if we set that equal to 0, we get d equals 0, 0, and 0. Okay. So that then would be C3 e to the 0x, which is nothing, plus C4x e to the 0x, which is nothing, plus C5 x squared e to the 0x. So that's from yesterday. Not yesterday, I guess, 4-3. So again, this is C3 e to the 0x, C4x e to the 0x. I'm just not including the e since it becomes 0. You have a repetition of 2, that's why you get the x and the x squared. Okay, with me so far? Okay, so this, like we said, is your complementary solution. This is going to be your particular solution. Now, how many constants should we have in our solution based on the original equation? 2. Second order, there should be 2 constants. We are not allowed to leave all 5 of these. Particular solution does not have constants. So we're going to have to find that C3, C4, C5. These 2 are going to stay. Okay, so next thing that we are going to do is we are going to return to the original differential equation. Okay. We are just going to look at the particular solution. So we have C3 plus C4x plus C5x squared. If we return to our original differential equation, we're going to need the first derivative and the second derivative. So we're going to take the derivative of this. We get C4 plus 2C5x. Second derivative then is going to be 2C5. Quick note, I believe your book uses A, B, and C instead of C3, C4, C5. I'm going to keep it like this, but I think A, B, C is normally a little easier to use so that you don't drop any of the subscripts. Okay, so now we are going to substitute all of these into the original differential equation. Okay, so it was y double prime plus 3y prime plus 2y. That gives us 2c5 plus 3, the quantity c4 plus 2c5x. Add 2 times c3 plus c4x plus c5x squared. That all needs to be equal to 4x squared. Doing a little bit of distributing, I get 2c5 plus 3c4 plus 6c5x plus 2c3 plus 2c4x plus 2c5x squared equals 4x squared. So we need to find c3, c4, c5. Okay, there are 3 different terms that we see. We have all the terms that have an x squared, we have all the terms that have an x, and then we have all the terms that are a constant. So I'm going to look at those separately. X squared, I believe, is just this term. So we get 2c5 is equal to 4. So I'm going to divide out the x squareds. Our c5 then is 2. If I look at all the terms that have an x, I get this one and this one. So we have 6c5 plus 2c4 equals 0. Our c5 is 2, so 12, move that over, get negative 12 divided by 2. We get c4 is equal to negative 6. Are we still good? Okay, constant, we get 2c5 plus 3c4 plus 2c3 equals 0. So this is 4 minus 18 plus 2c3 equals 0. Hence we get c3 equals 7. And now finally we go to our solution. Our solution, again, is the complementary solution. Add the particular solution. Our complementary solution was c1 e to the negative 2x plus c2 e to the negative x plus c3 plus c4x plus c5x squared. Okay, few warnings to you. Make sure you have the right number of parameters. We already said 2 parameters because it's a second order differential equation. When is it possible to find C1 and C2? Okay, if I gave you the initial conditions. Pay attention when you're doing the WebAssign on what you are asked for. WebAssign will sometimes ask for the entire solution. Sometimes it asks for the particular solution only. So make sure you pay attention to that. And then, quick reminder. This ended up being really nice to solve for C3, C4, C5. Sometimes it's not as nice. Sometimes it's going to be a 3x3 system. Are you all comfortable solving 3x3 systems? Yeah, we're good with that? Okay, maybe like you can't do it right this instant, but could we figure it out?
Yeah.
Okay. Are you guys ready to try one yourselves?
Yes.
Wonderful. Okay. Do you think you can do the whole thing, or do you want to get like halfway and check and make sure that we're on the right track? Okay. Wow, we're feeling good. That's great. Okay, the one that you are doing is y double prime minus 3y prime is equal to 8e to the 3x plus 4 sine of x. Okay, this is a long problem. I definitively want you to do this with the person next to you. So, turn, say hi. If you want to move your desk, it wouldn't be like a horrible idea. You got 5 minutes. Let's see how we do in 5 minutes.
Yeah, I think so. So let's the one that starts with a C. We gotta annihilate. We learned that earlier. No, don't worry, I got it. Yeah, hold on. I just have to write down annihilate. Okay. Exponentials, right? So it's going to be d minus thing in front of the x. D minus 3 to the, is there an x in front of it? No. So it's just going to be d minus 3. Multiply by both things, right? Yeah, so there's going to be a d minus 3. And then let's move on to the sign annihilation. It's going to be okay, so alpha is 1. Okay, so that means nothing. Or alpha is 0.
Okay, can I pause you real quick?
Oh, yeah.
When you get to the last part of step 2, where you have y equals whatever the whole solution looks like, can you show me? Because if that's wrong, then you're in trouble. So show me when you have y equals your complementary with equal solution before you find your c.
Plus e, so that's the 4. No, that's just the 1 squared. So it's going to be e squared plus 1. Then where does, what about the 4? I don't think that matters. Don't you mark out? Oh, yeah. Oh, yeah. Yeah. Okay, easy. Okay. And then multiply that. Okay, so it's d minus 3, and then d squared plus 1. And we multiply that by what? The left side also.
Alpha is 0.
So we multiply it by the way you jacked it. So like d minus 3. That's equal to 0. But we also have to throw a y in there. Oh yeah. Otherwise, we're multiply that out. Oh, then we find we find the zeros. Then you just say d. Wait, d3 equals 0. Or do we? Oh, we put this thing into equal to 0. Oh, okay. Oh shoot, I don't need this. Minus I. Right? Yeah. Okay. So then our y equals 1 plus 2 and then it's going to be C3 actually, oh yeah, because I was about to do that. Right, we have to do it twice, plus or minus. Oh no, this counts as a roll even. So like we have, so basically we're just doing that.
From setting this
Two?
so you set that at
Here, hold on.
So these two give you the complementary. This, the annihilator, this gives you particular solution.
Wait, no, I messed
And then this is back to section.
Oh yeah, this is fine.
When you solve
We just
it, you
do,
got
yeah, so it's gonna be, so there's no E,
get M1,
it's
M2,
gonna be,
M3, let's say.
I think it's
You get M1, M2.
C4 cosine of x plus C5 sine of x.
Except when you have
Okay, should we ask her? Yeah. Okay, Miss Golden.
you're gonna get the 0 and 3 that you have to play. So now you
Step
plus or minus I.
That made me sweat.
So now you go back to complex solutions.
Okay, can you
This one's repeated.
Oh.
So it's repeated from a different part of the equation.
Oh, it still counts as okay. So it's gonna be C3x even? Yes. So it's a period. Okay.
That's all the way back to section 4.3.
Okay. So now step 3, right? Yes. Come back to original GP. Do YP equals whatever it was. So C3x is 3x.
You have your 4.3 notes.
Here we go. So we did YP equals all the part that was. We have a beta. And then we found the derivative. I don't know how many times we do it. But just two, because our original equation. Oh my gosh, out of control. Okay, it's fine. So C3x no C3 3 C I'm gonna be on the inside.
It might be easier to use
Okay, can we do that?
You don't have to.
No, I'm just saying. I agree. Because easy to use threes.
Yes.
Because the only thing going through my head is 3CE, like the makeup brand.
Okay, pause real quick. Do we all have the general y equals?
Yeah.
Okay, can we check that? Because I haven't seen all of yours. Here is what I got. Oh, you can't see that. So this is your complementary solution. This should have been your annihilator. So this is the general. This 3 counts as repeated. It happens here, it also happened up here. So this is your particular solution. Okay, you guys need to look back at the 4.3 notes. Because you guys keep asking me, where did this come from? Where did that come from? Where did that come from? Came from solving the homogeneous. So these two are from your two imaginary roots, your plus or minus I. I will tell you I used A, B, and C going on. You don't have to, but just know that when you look at my work later, I'm going to have A, B, and C. 5 more minutes. Do we think that is good to finish? Okay.
Oh, those two things are those two things are the same thing. But that's
Okay, 9ax e to the 3x plus 6a e to the 3x minus b cosine x minus c sine x. Okay.
And then we
Go back to here.
right. Wait. Plug that into the OG. Okay, I'm gonna write it again. So it's y double prime. Oh no, minus. Oh, it's right there. Okay, so we. Oh shoot, I put all that in. Okay, that's fine.
Just rewrote this. I don't want to rewrite it.
there's gonna
No, I straight up forgot the X. It wasn't possible.
Wait, I'm literally multiplying out or like distributing as I go.
Really? I can't do that.
Wait, she was also a negative.
It's actually not that bad.
Okay, I'm gonna try it. Let me just confirm. So, the A is
The problem is that Lee is here.
Goodness gracious. Okay.
you when we set it equal to the thing.
Yeah. Oh,
The things cancel.
the 9x.
Are you two doing okay?
Oh, this canceled.
Sam, are you doing okay?
This canceled.
Do you need?
Part of the
Okay.
X cancels if I did this correctly. Only half of it though. Oh my gosh, wait. Things simplify.
I don't know if I'm being dumb or my brain hurts. This and this.
Yeah, that's
But
the
wait,
only thing.
only-
Yeah, only.
Half of it.
Yeah.
And then does a b cosine x turn into a 2b cosine x if I add it with
But where's the-
3b?
Wait, where? That's a sub. It's a C though.
Oh, oops.
I'm gonna rewrite it.
Are you done?
And now my head hurts. And I've been writing my b's from the bottom now, and I hate it.
Yeah. Okay, so now we just I don't know what to do next.
Because it's not as clear as it was before. Okay, Anna. So we put all the signs in that.
I mean, it's actually. We must do the E and the X's first.
Okay, yeah.
So we do. So it'll just be 3A is equal to 8, right?
That's good.
Oh, okay. Good.
Is this 8? I think it is.
This is from. And then should we do the? We have to make it. Let's do the. Which ones should we do next?
Can we just do like signs? Or do you
Yeah,
have
let's
to?
do signs. So.
Is that a thing you can do?
Yeah, why not?
Okay.
So it's then 3B minus C equals 4. And if we do cosines, it's minus 3C equals 0. And then we can just do system.
Okay, I'm gonna give you like 3 or 4 more minutes, and I'll show you what you should have gotten.
No, I got negative
Oh, okay.
this. Sorry, it took me a while to simplify 4 over
Oh, I
2.
see. My main struggle right now is I'm trying to do 4 minus 2 quints.
That's brutal. I didn't think I should be.
Oh, do that the better way. You put it into the other thing?
Yeah, I think I slipped it in the other way.
Oh, that makes more. That's easier.
The actually, the 9C3 actually did 3 on top.
6 over
Alright.
5 equals
Time for the final answer.
So C3
Wait, did you use
equals.
fixed it? Yeah.
Wait, hold on. So we write our answer as, or you just like two bits is the C though, not the B.
Oh, my bad.
Yes.
Okay.
That's all I got.
Good?
You're like the smartest girl in the world. You're so smart. Thank you.
So easy.
Do you ever feel like the smartest girl in the world?
Rarely.
Oh, really? Like, when you can do this easily, and we're here, like, struggling, taking 15 minutes to do a question, do you feel smart?
No.
Oh.
Okay. Bottom is what I got.
And do you want to make 5 thirds?
Okay. I think it's clear that we need to do our homework for 4.3 and 4.5. Some of us. Because we definitely struggled through this. I don't think it's particularly difficult, just very tedious. Like you take the derivatives, you solve a few systems. Okay. Thoughts? Okay. Can I heavily suggest that you try this homework tonight before coming to class tomorrow?